In the vast silence of the universe, where light from distant stars travels for millions of years before reaching us, something extraordinary crossed the boundaries of our solar system, an uninvited traveler, carrying secrets from another sun. For months, astronomers around the world watched in disbelief as their telescopes picked up a faint, icy body moving at impossible speed. Its name, Comet 3I/Atlas, the third confirmed interstellar object to ever visit our cosmic neighborhood. But unlike the mysterious Oumuamua or the hyperactive Borisov, this one held answers humanity had been chasing for centuries. And when the James Webb Space Telescope, the most powerful eye ever opened to the universe, turned its gaze toward this visitor, what it found rewrote everything we thought we knew about how worlds are made, how stars exchange their chemistry, and perhaps, how life itself travels between them. It all began with a faint glimmer in the outer solar system. In 2023, a team of astronomers scanning deep space survey data noticed something moving against the background stars, too faint to be a typical comet, too fast to belong to our solar system. It wasn't bound by the sun's gravity, it was merely passing through. Early observations confused even the experts. Its brightness fluctuated unpredictably. Its coma, the hazy cloud of gas surrounding the core, didn't behave like a normal comet's. Some believed it was breaking apart. Others speculated it was an entirely new class of interstellar debris. For weeks, the scientific community buzzed with debate. Was this an interstellar asteroid, like the enigmatic Oumuamua? Or a frozen relic from another solar system, a time capsule of alien chemistry? To settle the mystery, astronomers turned to humanity's newest and greatest instrument, the James Webb Space Telescope, orbiting 1,000,000 miles from Earth. When Webb locked onto 3I/Atlas, its infrared eyes pierced the darkness that had hidden its secrets. What the telescope saw stunned scientists across the world. Using its MIRI spectrometer, Webb detected distinct chemical fingerprints in the comet's light, traces of methane, carbon monoxide, silicates, and complex organic compounds. But these weren't just ordinary elements, their isotopic ratios, the subtle fingerprints of where they formed, were completely alien. It was official, 3I/Atlas didn't come from our solar system. It came from somewhere else entirely. Imagine that for a moment, an object forged in the furnace of another star, traveling for millions, perhaps billions, of years across interstellar space, only to pass briefly through ours. Every molecule within it, every grain of dust, carries the memory of a distant world. In the lab, scientists compared 3I/Atlas's chemical signature with comets from our own system. The differences were profound. Its carbon monoxide levels were unusually high, and its hydrogen-deuterium ratios didn't match any known solar pattern. This meant the comet was formed in a colder, more distant region, possibly around a red dwarf star or in the icy outskirts of a protoplanetary disk far from its sun. It was, quite literally, a frozen echo of another world. Each gas molecule Webb detected told a story, of chemistry shaped by different starlight, of ice forged under different temperatures, of dust touched by alien radiation. This was more than a comet, it was a messenger from another star system, a piece of cosmic evidence proving that material exchange between stars is not rare, it's universal. Long before it reached us, 3I/Atlas had been drifting silently through interstellar space. Without a parent sun to warm it, it remained frozen and inert for eons, a crystalline capsule preserving the chemistry of its birthplace. Then, perhaps by pure chance, gravity pulled it toward our sun. As it approached, sunlight began to warm its icy surface, awakening it after millions of years of slumber. Jets of vapor burst from its nucleus, forming a glowing tail, its first breath in untold ages. The James Webb images captured these eruptions in stunning detail, tendrils of gas spiraling outward, carrying organic compounds into the void. For astronomers, it was like watching an alien world breathe for the very first time. But the most astonishing revelation wasn't just what Webb saw, it was what this meant. Every time a comet like 3I/Atlas crosses into a new star system, it carries the chemical fingerprints of its origin. Some of those molecules may even seed other systems with the ingredients of life, amino acids, carbon chains, and water ice. This discovery confirmed something profound: the galaxy is not a collection of isolated islands. It's a living network of material exchange. When stars are born and die, they don't keep their matter to themselves, they share it. They trade dust, ice, and gas across the cosmic sea. Our own solar system may be built, in part, from the remnants of long-dead stars, and one day, material from our world might drift into another, carried by comets just like 3I/Atlas. The universe, it turns out, is not static. It's constantly communicating through particles and light, a galactic dialogue billions of years in the making. For scientists, 3I/Atlas wasn't just poetic, it was practical. Webb's high-resolution data gave astronomers their first detailed look at interstellar ice chemistry. It offered a direct comparison between the building blocks of our solar system and those formed elsewhere. Dr. Elena Gossard of the European Space Agency described it best. It's like finding a message in a bottle, but this bottle has been floating through space for millions of years, carrying the story of another world. Through spectroscopy, scientists identified organic molecules similar to those found in our own comets, including methanol and formaldehyde, compounds that, on Earth, serve as precursors to amino acids. That raised a thrilling possibility: the same chemistry that helped life emerge here could exist throughout the galaxy. If interstellar comets are common, and data suggests they might be, then the seeds of life may constantly be traded among star systems, scattered like pollen across the universe. Despite its significance, 3I/Atlas was never destined to stay long. As it passed near the Sun, the intense heat caused it to fragment, just like many of its ancestors. The comet began to break apart, leaving a trail of debris that will drift invisibly through the solar system for decades. And yet, even in destruction, it fulfilled its purpose, revealing its secrets before fading back into the void. What remains now are the data, the spectra, and the awe it left behind. Thanks to Webb, humanity captured a moment that may never repeat: a cosmic handshake between two star systems. There's something deeply humbling about realizing that the dust from another world just passed through ours. For centuries, we looked at comets as omens or signs of divine intervention. Today, we see them as carriers of truth, remnants of creation, linking us to the broader galactic story. When we study objects like 3I/Atlas, we're not just learning about distant stars, we're learning about ourselves, our origins, our place in the universe, and the unbroken chain of chemistry that ties us to everything that ever existed. Each discovery like this redefines what it means to be human: curious, small, yet capable of reaching across the cosmos with our instruments and imagination. In a few million years, 3I/Atlas will have traveled far beyond the reach of our sun's gravity. It will continue drifting endlessly between the stars, silent, cold, and eternal. Somewhere, perhaps, another civilization will see it glowing faintly in their sky and wonder where it came from. Maybe, with their own telescopes, they'll detect traces of our system, elements unique to our cosmic neighborhood, and they'll realize, just as we did, that the universe is one continuous story written in stardust. Because every comet, every grain of dust, every molecule of water that exists, all of it, is part of the same endless narrative: stars are born, they die, they scatter their remains, and from that, new worlds rise. And now, thanks to the James Webb Space Telescope, we can finally read one of those chapters in full. Comet 3I/Atlas wasn't just a visitor, it was a revelation that a frozen messenger carrying the signature of another sun, that a reminder that the universe is vast, connected, and endlessly creative. In its brief encounter with our solar system, it gave humanity something priceless: proof that we are part of a much larger tapestry, woven from the same dust that drifts between the stars. So the next time you look up at the night sky and see a comet streak across it, remember, it may not just be from here. It might be a traveler from another world, passing through, whispering stories of creation across the cosmos. And somewhere out there, in the quiet dark, another eye might be watching us too.